Hello, and welcome to the PyTorch Summer Hack 2020. I'm Brad Heinz, and I'm a partner engineer with the PyTorch team. If you're not sure what a partner engineer is, it means that my day job is making sure that developers like yourselves get the most they can out of PyTorch and related products. In this video, I'm going to give you a walkthrough of setting up the PyTorch mobile runtime in an iOS project. To follow along, you'll need Xcode version 11 or higher on macOS. You'll need to have CocoaPods installed. And if you want to deploy to a device, you'll need an Apple developer account and an iOS device running at least iOS 12. You should also be using PyTorch 1.5 or higher. PyTorch offers native runtimes for iOS and Android, allowing you to bring your machine learning app to mobile devices. Including the library in your project is a one-liner, but there is more to do getting set up for best performance on mobile. In this video, I'm going to show you how to set up your project to include the PyTorch runtime, how to export your model to TorchScript, PyTorch's optimized model representation, how to further optimize your model for best performance, how to add your model to your Xcode project, and how to call the model from your code. Let's dive in. For this demonstration, we're going to build an image classifier into an iOS app. First, we'll create the project. I'm going to create a single-page app with UIKit UI. Now close Xcode and switch to your command line. So here's the pod file we're going to attach to this project. You can see it specifies iOS 12 and PyTorch 1.5. So now pod install that, and we'll open the workspace now instead of the project. It's important when you're using CocoaPods. And then we'll go ahead and run the project just to make sure all is well. And there's the sim. Nothing there yet, no surprise, so we'll stop that. The next thing we'll need is a UI. I'm going to have one image view, one button, and one text view in my app. The image view and text view will have outlets in the view controller, and the button will have an attached action. Rather than making you watch me set up a bunch of storyboard constraints, we'll do a little movie magic. Et voila. Now I'll show you how to set up and optimize your model for use with PyTorch Mobile. So first things first, we'll import PyTorch and TorchVision. And this is a good place to point out that you should be using PyTorch 1.5 or higher for this example. In the next cell, we're going to create a PyTorch model object. Now for the actual app, I have a pre-trained optimized model ready to go. But for the optimization process, I wanted to show you this on a custom model so that you could duplicate the process with your own models. This model happens to contain some very common layer types, a 2D convolutional layer, a 2D batch norming layer, and a rectified linear unit for activation. And the forward function just strings those three operations together. So now that we have our model, how do we optimize it? First thing, let's get an instance of the model. In my get model helper, you'll notice that besides just instantiating the model, I call m.eval. So eval turns off things in the model that you don't want on during inference time. Training only layers like dropout, automated gradient tracking, all this training related stuff eats up CPU cycles and we don't need it for inference. So we're going to make sure the model's in eval mode. The second thing we're going to do is some layer fusion. Fusing layers means taking multiple operations and combining them together into a single operation. This improves performance and memory footprint. Now, with the fuse modules method that I'm going to show you, there are only certain combinations of layers that you can fuse together. I'm going to refer you to the documentation for the latest information on that, but here we're going to try to fuse together a convolution, batch norm, and a ReLU. Once modules are fused, the next thing we're going to do is quantize the model. PyTorch tensors default to using 32-bit floating point numbers as their underlying type. When we quantize, we're going to change that to an 8-bit integer. This will perform faster and reduce the model's footprint both on disk and in memory. The final thing we're going to do is save the model as TorchScript. TorchScript is an optimized format for your model, including both your computation graph and your learning weights. It's meant to be consumed by the PyTorch Just-in-Time Compiler, or JIT, which is included with the PyTorch mobile runtime. So once it's exported, we'll save. Now, there are subtleties to layer fusion and to quantizing your model that you'll want to be familiar with when you're optimizing your own model for use with PyTorch Mobile. All of this is covered in the PyTorch documentation for quantization, which I encourage you to check out. Now I'm going to pull in the resources for this project. They include the model, so in my case that's an optimized version of MobileNet v2 trained on the 1,000 categories of the ImageNet dataset. We also have a text file that contains the human-readable labels of those 1,000 categories. And finally, we have an image file for our classifier to work on. There should be links to a sample project that includes these resources wherever you got this video. Now we can flip back to Xcode, and I'll add the 3 files to my project. Now, how do we call PyTorch from our code? Because PyTorch is implemented under the hood in C++ with libtorch, we need a wrapper for that C++ library. So we're going to go ahead and create a new group in the project. We're going to flip back to the command line, and I'm going to add these 2 files, torchmodule.h and torchmodule.mm. Again, these should be available wherever you got this video. And then Xcode is going to offer to make a bridging header for me. And I'm going to let it do that. So you can see here in the header, there are only 2 methods that are really interesting. One, which initializes the PyTorch runtime with a model, which is stored as a file. That's our model resource in our project. And the second one that does the actual prediction when you pass it in a buffer full of image information. And you can see the C++ bridge code in torchmodule.mm. And now I'll add my image resource to my image view so we can see what it is we're classifying. And speaking of images, I'm going to add one more source file. And this is going to be in addition to the UI image framework class that allows us to resize it more easily. The particular model I'm using, because it was trained on ImageNet, expects 3 color images sized 224 by 224 pixels. So this helper will help me achieve that. We have some stuff to fill in the UI view controller. First, I'm going to add a lazily loaded instance of our module, our model. You can see I'm loading it from the file and initializing the torch module object with it. Also, I have a lazily loaded array of strings, the labels, those 1,000 human-readable labels for the categories that the model recognizes. I'm also setting that up here. Now you notice we got an error on the torch module type. It's because we have to go back to the bridging header and make sure we include torchmodule.h. If for whatever reason your project isn't recognizing the type, go check the bridging header, make sure you've included the header for torchmodule.h. Now we're going to fill in the body of our inference buttons action. And you can see here we're going to load the image. We're going to resize it to 224 by 224. We're also going to normalize it. So just as with the size of the image, our model expects the image to be normalized in a certain way, and we have a method to do that. And finally, we take our image buffer and we pass it to module.predict. After that, we retrieve the label for the predicted category and display it in our text view. So now, at last, let's run our app. And you'll see it starts up, and there's our kitten. We press the Infer button. And be aware that even if you run this on a laptop, it may take a minute to run the first time. But there we are. Our model thinks that this cat is a cat. And that is how you get a PyTorch model onto iOS. Thanks for participating in the hackathon, and thanks for watching this video.